Hello everyone, so welcome to another a question of dynamic programming, and this is called house robber. So as the problem statement says that you are a professional robber planning to rob houses along the street. Okay, each house has a certain amount of money stashed. So we will be given an array. So every value of that particular array is kind of money in that home. So every element is a home, and the value in that particular element is the money. Okay, the only constraints stopping you from robbing each of them is that the adjacent houses have security systems connected, and it will automatically contact the police. Oh, okay. So we cannot consider the adjacent values. So if you consider 0, then the next number we'll be considering will be 2. Okay, will be like just in one gap, we can say. We cannot pick the continuous values. Okay, now given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so this is a dynamic programming question, and let me explain the question. We'll take an example, that given example, the first one, like the nums equals to 1 2 3 1, and the output is 4. Explanation like is given like 1, and then we only can take 3, then we will compare the max and maximum 4. That's what the answer is 4. So let's try this in our whiteboard. So as per the question, let's take this example. The homes are given as like what, 1 2 3 and 1 again. Okay, as per the question, right, if we consider 1, then we cannot consider 2, we only can consider 3 in this particular case. The total amount we can rob is like 1 plus 3 equals to 4. Now if we start from 2, we cannot take 1, we cannot take 3, so the only amount we can take is 2 plus 1, that is 3. So max of 4 and 3 equals to 4. So the answer will be 4. So now if you put in dynamic programming, so let's put an array for this particular one, like 0th index, like 1 2 and 3, right? Now let's start from, we're going to start from 0th index. Now if we start from 0, at particular 0 element, how much maximum amount we can pick? We don't know anything ahead of this, right? So at that particular moment, when we are robbing at 0, at that particular time, what is the max? So the max will be the amount assigned to that particular element, right? The 1, because we don't know anything ahead that is ahead of us. At that particular moment, when we are starting at 0, what is the amount? Max amount is 1. Same way when you go to 2, because we cannot consider adjacent 1 and we don't know anything ahead of us, when you're going to the index 1, the amount we can consider is 2. And now the original considering the saved value will start, means original DB will start from position 1, position 2. So what's going to happen now? If the robber starts from here, what's going to happen? If he starts from here, he gonna pick the amount for this value, that is 3, and we don't know ahead of anything, right? But we have calculated up to that value, up to that house. So if we pick it, either he can take that amount or he can't take it amount, right? If we take this amount, what will be the maximum? Only he can consider is the 0th house. So if he takes it, then the total amount will be 3 plus 1. Now another choice is if he don't take it. If he don't take it, only amount left is the 2, right? And that amount will become, if don't takes it, then the total amount will be 2, only this house, right? Okay, so what will be the max amount for 2? For second position is like max of this and this, that is 4. Now the robber went to here, right? So went to the third position. So in third position, if he takes it, so the total amount he takes is just 1 plus 1 home away from it, that is 1 position, that is value is 2, so total is 3. If he don't take it, he can only take the second house, right? And that is 4. So what will be the maximum? Is 4. So our answer will be the last value of our DP. That is 4. Hope you are clear. It's very easy problem. Just like we have to consider, just like when we solve the, you know, what is that? We solved the stair problem. You see that either he can take 1 step or 2 step. The staircase problem, it is exactly the same, just in opposite direction kind of stuff, but the understanding is the same. The logic remains the same. Here we just get the maximum, there we just used to keep adding the values. Here we're gonna just compare the values, but it's the same, either one this home or that home, just like in that problem we used to take 1 step or 2 step. So now let's go ahead and implement the solution. Okay, so first thing first, we're going to create our DP array. As DP equals to array. Wait a minute, we don't even have to create DP, we can use the same num, I think, because we don't want any kind of yes, because see, we don't gonna use the previous value anymore, so definitely we can use the same num, same array to derive it, so that we can make a space, you know, you don't have to use extra space. It's just OFN time, and space will be OF1. Whatever space we got, we're going to utilize that space. We're not going to space will be OFN for that particular array, but we don't have to create extra OFN space with the DP array. So let's use the same, because we are not using the previously value again, we're gonna just use the same array. Okay, so now for let I equals to 0, oh geez, I equals to 0, nums dot length, that is what are you going to do here? We're going to cast amount or cast amount, we can say per home. The value is cast, right? So now if I 0 1 is less than 2, we just have to continue. We don't have to change the values of first two elements, right? Because those values will stay the same. Now for 0 1, for second position the game will begin. So for second position, nums of I equals to math.max nums of I plus nums of I minus 2, yeah, or nums of I minus 1. I think we did it. That's all it needed. And at the end we just have to return nums.pop. Let's see if our house robber problem is here. Decode the what. Okay, let's go to dynamic programming. Where is the house robber? House robbery money. Then you're gonna okay, I'm sorry, syntax errors. Our logic is good. This would be nums and syntax. Nums. Yeah, everything is correct now. It should work. Perfect. As simple as that. So yeah, we avoided creating a DP array because you know we are not using the previous elements when we are going ahead. We are just replacing it, so we don't need a extra DP array or OFN space to calculate it. We can use the same space to calculate it, and that's that. So in OFN. So thank you.